You have learned that solving linear equations is about finding the value of the unknown while balancing both sides of the equation. How about solving a linear equation with surds, like this one? We can solve for x, treating these as the coefficients of the x terms to obtain this. We know we can simplify this further to give us x equals square root of 10 over 5. Now, is this equation similar to the previous one? It's different because the unknown, x, is under the square root sign. To have only x on one side, we need to first get rid of the square root, and we do know of a way to do it. Recall that squaring a surd like this will get rid of the square root. That's exactly what we are going to do in this video to solve equations involving surds. Let's look at this equation again. We know that we need to square both sides of the equation to keep it balanced. And here we have a linear equation. To find x, we can subtract 2 from both sides of the equation, and we will get x equals 7. Finally, we need to check our answers in the original equation. We substitute x equals 7 into the left-hand side, and taking only the positive square root of 9 gives us 3, which is the same as the value on the right-hand side. This means that x equals 7 is a solution to the equation. Next, let's look at a similar question. The only difference is that there is a x term on the right-hand side as well. Can we still use the concept of squaring both sides to solve it? Let's find out. Squaring both sides of the equation will give us this. At this point, you must take note that we are squaring the sides and not the terms. Upon simplifying, we see that we get a quadratic equation that gives these two values of x. Now let's check our answers in the original equation. Substituting x equals 1 into the original equation will give us the same value. This means that x equals 1 is a solution to the equation. Now notice that the values are different when we substitute x equals negative 4. This means that this answer does not work in the original equation. So what went wrong? Well, recall that our first step was to square both sides, and then we get a quadratic equation. Both answers satisfy the new quadratic equation, but not the original equation. In other words, when we squared both sides of the equation, we actually changed the equation in the process and introduced an extraneous solution that is not a solution to the original equation. Note that we can use NA to indicate that the extraneous solution is not a solution to the equation upon checking the answers. Hence, it is important that you check your answers when solving such equations. Let's try this question that seems a little more difficult. Here, the square root and x term are on the same side of the equation. Will squaring both sides of the equation get rid of the square root? Let's see. Upon squaring both sides, we run into a problem. Recall that the point behind squaring both sides was to get rid of the square root, but there is still a square root in the problem. Let's take a few steps back and look at the equation again. To avoid the problem, we need to make sure that we've got the square root all by itself on one side of the equation before squaring. To have that, let's subtract x from both sides of the equation. Now, squaring both sides will give us this. And again, we will get a quadratic equation that gives us these two values of x. As always, let's check our answers with the original equation. Since the value on both sides is the same, it tells us that x equals 2 is a solution to the equation. However, x equals 7 is an extraneous solution as the value of both sides are different and is therefore not a solution to the equation. At this point, let's do a quick summary of what you have just learned. To solve an equation containing one square root, first, make sure that the square root is by itself on one side of the equation. Next, square both sides of the equation. Then solve for the unknown. And finally, check the answers with the original equation. Finally, let's look at one more question where there are two square roots in the equation, like this one. Now, did you notice that each square root is by itself on one side? This actually makes it easier. Now, can squaring both sides get rid of the square roots? Let's find out. Upon squaring both sides of the equation, the square roots are no longer around and we get a linear equation. Solving for x will give us x equals 3. Again, let's check the answer. Substituting x equals 3 gives us the same value, 4, on both sides of the equation. Hence, this is a solution to the equation.